Question number 14 state that an object moving in a horizontal circular path has a mass of 0.8 kg and is attached to the end of a massless rope. Well, many things, that has a length of 2 meters. If the object speed is 2 meters per second, then the tension in the rope is equal to. Anyway, actually, there is a missing law here. It's not put here. Okay, let me just put it now. I think, yeah, it's acceleration equals velocity square over the r. Okay. Oops. Here's r. Anyway, this is r. Okay. Yeah. This is acceleration for circular movements. For circular movements, this acceleration we will have. Anyway, what we will do now, we will use two laws. Some question will come to you in Saat. They or you have to utilize two laws here, first and second. Just you find something from the first law, then you will utilize it in the second law. The second law here we will use. Okay, let's just find the acceleration first, because we need acceleration. Why? Because we will use again Newton law, second Newton law, FMA. Why? Let's see the question again. We have the mass, okay, but what we are asked. We need what we are asked. Then the tension in the, yes, we ask about the tension. Tension means what? The force, isn't it? So we have the mass and we wanted to find the force, but we don't have the acceleration. How just to find it? Because it is circular path here. Okay, because it is circular path. So we will just use this law here. So it will be what? A equals V. What is V? Okay, let me see. Yes, 2, isn't it? 2 meters per second. So 2 square over the R. R, it is the length of the rope, because if you notice that it's circular, the center, this is the rope, this is the object, this is the R here. The object will move like circular pathway. So this is the center here. So this is the R. So this is the R here. So here is 2. So R how much? Also 2. So it will equal to how much? 4 over 2. It will equal to 2. Fine. Okay. So now if we use 2, now we have A. Now we have A and we have M. Great, Yusuf. Congratulations. That's nice. You have answer actually. Because why now? If we utilize it, let's just check, Yusuf. Just give us 1 minute here. M here we have 0.8 times, oh my God, yeah. The A here is 2. Okay, so 2 times 8, it is 16. Because we have a comma, so it will comes left 1 time, so it will be 1.6 Newton. So V. Is it clear? Number 17. The figure shown represents a projectile's motion. Which of the following is true regarding its speed? Okay. Here's the thing. You have to focus in two main points in projectiles and make it simple to you as much as possible. There is two let's say, what's called this, two components of the movements of the projectile object. What are these? Vertical and horizontal. Okay, vertical and horizontal. Okay, we will see, guys. We'll see the answer. Good job. Just to say this. Okay, let's just explain it and we'll confirm your answer. Nice. Okay, so we have vertical and horizontal. For the horizontal, it will be constant through all the movement of the projectiles. Okay, but for the vertical, no, it will be change. There will be somehow a change depending on the law of the motion, as same as the law that we have used before, Vf equals Vi, but here the acceleration will be G. Either it will be plus or minus G times time. To find what this is for vertical. Let's go to the question. The figure shown represents a projectile's motion. Which of the following is true regarding its speed? So now I see two answers here from Dawood and Manar. They are saying C. So let's see the from A and B. We have here A and B. the speed or the speed are they the same speed? I don't think so, because at the highest position here, B, it will be 0, the speed. There will not be no speed here at all. Okay, don't think about B at all. خلاص. يعني anything here we have B, we will not consider it from the options, because A and C, they have the speed, but B, there is no speed, because it will be like stop points here. Okay, so this will cancel it. We don't want it. And even this, we don't want it. Okay, there is, okay, let's just keep it. Let's see the next one. Or even this, we will cancel it. So you're right, guys. Yes, C. Clear? Okay, now we'll go to the inclined surface. We have 30 Newton force acting on a box with a mass of 3 kg from the east. Calculate the frictional force. The coefficient of the kinetic friction is 0.2. Okay, lengthy question. No problem. So now, what we want. First thing, let's see what we want. We want frictional force. We know frictional force before that. It is F equals to mu times Fn. Okay, F equals mu times Fn. All right. We have the coefficient mu 0.2. So this is, we have it. What about the Fn? How just to find Fn? We know Fn equals to what, guys? We say equals to what? Let me just see. Great, yes, it is the weight, W, let's say, which is M times G. M times G. Okay. Now, we want just to find this weight now from this box, for example. Okay. Okay. Now, how just to find it? Let me just draw it here a little bit. Just draw it. Suppose this is a box here. Okay. And this is the box here, for example. Okay, I say that the degree here is 60. Okay. 60, let's say 60 degree here. Let's write it here. Okay, it is 60 degrees. So now, if this is now the gravitational force coming here, the Fn always, put in your mind, always Fn will be the force perpendicular to the surface. This is Fn here. Okay, this is Fn perpendicular to the surface. All right. Okay. Okay. So, okay. If you notice this graph, maybe it's much better here. If you notice the graph here, you see this is N, this is Fn. Actually, this is normal to the surface itself, and we want just to find the weight. We want just to find the weight that equivalent to the Fn. If you notice here, this is a simple formula. Okay, this will equal to Fn. It is weight. Fn will equals weight times cosine theta. Okay, so now let's just calculate this one. Fn, what's the weight now? It's 3 kg. So it will be 3 times 10. Yes, you're right, Hamza. Great. 3 times 10 times cosine 60. So 3 times 10 will be 30 times cosine 60, it is half. Actually, you need just to understand the cosine 60, sine 30. You need to memorize them. These are very basic things, okay? So the half of 30, how much? 15. Okay, now we get what? We get Fn only. Now we want just to find, again, let me just make an area here. F equals 0.2, which is the coefficient, times 15. So how much this will equals? Hi guys, which is the answer now? It will be 3. Yes, D. So this is the question. Let's go to the momentum here. Momentum. Okay. Bicycle has a mass of 50 kg and a momentum of 250 kg meter per second. Its speed equals, okay, again, as the way that we have said that before about impulse, it is force with time. Now momentum, it is a mass times velocity, okay? It's velocity, actually, it's written speed, okay, but it's velocity because there is a direction. Sometimes they use direction, consider direction. Anyway, so now what is the answer, guy? We have P equal M times V. And we have the mass, it is how much? 50. Okay, we want to actually V here, and here 200. The momentum is how much? Momentum state here, 250. So it will be 250. So the velocity here, Hamza said, yes, you're right, Hamza. This is the way how just to play with the formula. Yes, you want to just divide now, 50 over 50. So 50 with 50 will cancel each other. So we'll have 250 over 50. So 0 with 0 gone. 25 divided by 5, how much? It is 5. Great. Question number 25. We have here this question. Calculate the amount of change in entropy for a sample of water that gains 600 joule of heat at 27 Celsius. All right, we have entropy. Entropy. This concept, entropy, okay, let me explain to you. It's similar to concept that we have explained yesterday. That's, for example, when you charge your mobile, remember? When you charge your mobile 100%, then after you are using it, you will feel like little heat there. This heat, it is a lost energy. Something is lost. Entropy just is trying to explain how the energy will be lost. So it will conclude that the universe is in chaotic situation. Okay, so and mathematical expression for entropy just includes the heat and temperature, which is this one. All right, it's very simple one. So let's just utilize it to solve this question. Okay, so what do you think now the answer here? What will happen? What will be? Anyway, it's somehow you see it's A. But be careful, guys. Be very careful. It's a tricky question. Why? Yes, Noah. Great. Appreciate that. You see here, temperature Celsius. Be careful. It's very simple question, but this is tricky in units. This is Celsius. But what's the unit of the answer? It's Kelvin. Yes, Noah. You're right. You are right. Yes, it is B. Why? What do we need to do here? As we have done before that, we need now just to convert first. You see, this type of question just contains 2 steps, okay? So we need just to convert first, just to say T in Kelvin will equal to 27 plus how much? 273. How much this will be? 27 plus 273, I think this will be 300. Yes, nice. Good. 300 Kelvin. So now if we apply this law, entropy law, Q over T, delta S will be equal, what's the Q here? It is 600 joules, so 600 over what? Over 300. It will be what? 2 joule per Kelvin. This is the answer here. This is B. The general law of the gas, let me just make a brief explanation here. You see, now we have 2 terms here, left and right, and this contains P is the pressure, okay? P is the pressure, V is the volume, and the T is the temperature. Again here, it happens that if you have a gas, and if this gas have a situation with a pressure, for example, equals something, volume equals something, temperature equals something, and at the same time, same gas that you make a little change in the pressure and in the volume, for example, okay? Using this law, you can find the temperature, for example, the unknown thing, okay? Because it is the same gas, and only if you change the volume or pressure from the first, from this side, and here if they are different also, okay? And you have unknown, one unknown, for example, temperature, you can find the temperature here, Okay, so it seems like here this is first situation of the gas and this is second situation of the gas. All right. So now you want to find the given data, and based on that you make a substitution here, and then you can find the unknown. That's it. A gas with 70 centimeter cubed at 100 Pascal pressure. Okay, what is its volume at 200 Pascal at constant temperature with the same units? Okay, so now it's mentioned that constant temperature here. If you notice that constant temperature, if it's mentioning constant temperature or even constant pressure or even constant volume, the way that you deal with it, just cancel the temperature. They are equivalent from the both sides. So you will end up with P1 V1 equals P2 and V2. Okay. All right. Just go up a little bit. Okay. Yeah. Then we have here, if we just make V1, it is 70 centimeter cubed, and we have the P1, which is pressure, okay, 100 Pascal PA, and we have V2. It is unknown, or it is question mark here. This is question mark. It's unknown. And we have P2, it is known, which is how much? 200 Pascal. Okay. So what do you think the answer using this this equation now?
Sir, I think it's B35.
Okay, I will keep this answer in my mind. Okay, good job. Okay, substitution here and calculation. V1, it was 70. P1 is 100. So 100 equal 7 times, I mean 70 equals P2 is 200. Okay, and this is V2. This is 70 here. So now? Okay, now if we just divide before just multiplying 70 by 100, just make it simple as much as possible if you can. And when you just make a calculation, divide 200 and divide 200 here. This 200 and 200 will gone. If you see here, these zeros 100, okay, and these zeros will gone. Khalas. This 100 was 2 zeros. Khalas, will gone. We will just end up with V2 equal to 70 over 2, which is equal how much? 35, as you have all mentioned. That's nice. So is it now I want from your side, all of you, just from this formula and from this question, I need the answer. Let's just read it. A mass of 1 kg is hanged on a pendulum with a period of 3 seconds. Okay. If we change the mass, okay, notice that now in first situation that we have, okay, it's hanged. This object is hanged and its mass is 1 kg. Okay. Now, if we change this mass, for example, let's just write it here. Change it, for example, into 2 kg and another pendulum into 3 kg. Okay, knowing that the first situation, the periodic time is equal T equal 3 seconds. Okay, now if we change the mass here from 1 kg to 2 kg and 3 kg, what do you think the periodic time here? What do you think the T here equals? And also for this case, if we change the mass, what do you think the answer will be based on this equation? So the periodic time will be what? What do you think? Will be different?
It will be the same as the first situation, which is 3 seconds.
Yes, the answer. Great, mashallah. So what do you think? What's the answer? A, B, C, or D?
Sir, it's A.
Yes. Fantastic. You're right. Why is that? As your colleague said that, in the periodic time formula, do you have any mass here? No, there's no mass. So it means that periodic time will not affect by mass. Even if you hang 100 kg, the same periodic you will see. The same periodic time you will find. Okay. If you change the length of the rope here, if you change it, then yes, the time will change. Okay. Or if you change the G, changing the G, it means that if you go to the moon, for example, or other planets, yes, periodic time will change. Okay. Same as the question number 5. It's talking about changing the G's. G. How it's stating here moon and our Earth, our planets here. So here's saying that when comparing the periodic time of pendulum on the surface of the Earth and a pendulum on the surface of the moon, okay, in which of the following cases is the periodic time is greater? Okay. Now, first thing that, do you think the periodic time will change now? Yes, it will change because of the G. G is different now. In the moon is different. It's less than the Earth, but in the Earth it's higher. So now, if let me just help you with this question. In the Earth, G, it is what? It is high. Okay. In the moon, it is low. So it means the G is low. So if the G here high, T will be high or low? Just write it down here. High or low?
To be low, sir?
Yes, you're right. To be low. So it means that in the Earth will be the periodic time will be low. Okay? And the moon will be it will be high because the G is low. You get it? I think. Okay, let's see now the option.
Inversely proportional?
What?
It's inversely proportional.
Yes, exactly. This is terminology in physics. Inversely proportional. It means that the parameter, if it's high on one side, the other parameter will be low, and vice versa. Okay. So for this reason, let's see now. Cases the periodic time greater. Now we want to just periodic time is high. We say that the moon here, the G is low, so the periodic time is high. So for this reason, now the periodic time of the moon will be high. So let's see now the answers. The pendulums on the moon's surface and the spirit. Here the pendulum. Yes. Now we'll focus on only A and B. We will neglect C and D. Why? Because you're saying that the Earth will be high. No, we say it's not high. Will not be high in the Earth. The periodic time will be low. Will be lower. And even the D, it's about the surface of the Earth. No, it will be low. Okay. We are now just limited with A and B. Now, what is the right answer here? Which one will be the right now here? What do you think? Now we have other part here is saying that it's a thread, which is the rope, 50 centimeter, and here is 100 centimeter. So what can? Yes.
B, because it's square rootable.
Great, nice. And Noha, yes, you're right. Why? Because this relation, if the L, the thread length is high, the T will be high. So now, if we compare both options, 50 and 100, we wanted just the bigger one. We wanted the longer one, which is 100. So this absolutely will be the bigger one in terms of periodic time. Okay, so the answer is B now. Clear all?